big this room.
Yeah.
Let's begin by introduce ourselves. Who are you, Sebi?
So I'm Sebastien Blanc. I'm half French, half Dutch. That's why I have this weird accent. And I'm a developer advocate for Ivan. And yeah, my role is to make developers happy. And I hope I will do that.
Okay, which weird accent? My accent is where I am Horacio Gonzalez. I am a Spaniard who has been living in France for over 25 years. So my English accent is, as you can see, really weird. And I work as developer relation at Clever Cloud, a French cloud provider. And we can begin.
Sure. So what will we be talking about today, Horacio?
I think we are talking about complexity. Let me explain that. When I began doing Java code almost 30 years ago, 28, something like that, you wrote your .java file in Notepad, usually. You added your dependency jars. You did javac, and you had a .class file. And then Java my class, and your application was deployed.
It was so easy.
Yeah.
Yeah, I loved it.
And now, if you are a developer and you want to deploy an application in Java, well, you need to know why more things. Docker,
Kubernetes,
DevOps, observability, Git,
Redis, I don't know.
infrastructure as code.
Yeah, a lot of stuff. Cloud
I mean,
providers.
If I were a student now, I would be scared. Only to deploy one application, yeah.
Yeah, because I remember when I was a student, I wanted to try out everything. And yeah, I would do the same.
And there are 100 of solutions for every problem.
Yeah, it looks almost a collection of JavaScript frameworks.
So we are going to talk about platform engineering and how it can, if it is well used, help to empower your developers and reduce this complexity.
Yeah, but before that, let's go back into the past.
Yeah, because we are getting old, my friend.
Yeah, I'll let you guess who is who. I'm taller than Horacio, so.
Let's go back at a time when internet was young.
Oh, the internet.
When Windows 95 was the cutting edge.
I love
Who here remember that, please? Hey, you are my people. When companies still use mainframe, no, sorry, it is still really...
Still a lot of companies are using mainframes.
But at the time, when we wanted to deploy something in productions, we put it in bare metal servers. It was rigid. It was very structured. It has control, it has reliability. It worked.
It was just working. But yeah, back in this time, it was the first time that big companies were doing IT projects. And honestly, they had no idea how to do that. And what they tried to do was applying the industrial model to IT development. And as you can guess, that was not really the best fit.
And not only the industrial model, the war classic corporate paradigm with all the silos, all the corporate politics, and all the walls between the different teams, separation of responsibilities, and all that.
Corporate silos.
Yeah. In fact, we were managing IT like factories. And why? Because we couldn't do it otherwise.
Because we didn't know how to do it otherwise. And yeah.
But as the sad cat, we weren't happy with that.
We were happy with that. And
of course,
and you will see that slide more often, whatever was being used, there was already some bash. And bash will be there until the end.
So let's advance in the time. We are now at the end of the 90s. Yeah.
Yeah.
Do you remember that?
Yeah. Who was making his war or ear file from Eclipse and then dropping that to production? I'm sure you did it, yeah.
Do you remember where you went to sites like Apache Commons in order to grab the last version of the library, copy it in your webinf lib folder in the project, and recompile the project? And if a new version was released, you needed to go to grab this new version and all that.
A lot of fun.
we knew at the time we could do it better, but we had no tooling.
There was no tooling. But the tooling started to evolve a bit.
Yeah.
And
One of the first steps in order to change things was having source control.
yeah, who had so much joy with ClearCase?
Clear case? Hey, yeah. CBS? Yeah.
And Subversion, that was already a revolution.
It
And
was better that...
it was better than, I was working with someone who didn't trust those tools. And what he did, he was printing out the two versions, and he was comparing that hand by hand, because he didn't trust those systems. But these were the old times.
For me, the second biggest step was having dependency management. At the beginning with Ivy.
Yeah, but I loved Apache with Ivy, but for me, the real game changer was Maven. It was pure magic, and it was, and we will talk about that later, it was the first time that you could have a declarative approach. Rather than a procedural approach like Ant, declarative, you expose how you would like your app to be built, to behave, and that was it.
And you could recover all your dependencies in coherent versions and being able to see if you have any problem of mismatching dependencies and all that.
Yeah.
Yeah. And what about test? Hey, Nacho was here before talking about test. Yeah. You could do now unit testing, integration testing, all that avec things like Unit or Hudson before it was renamed and Jenkins. You remember that maybe too?
Yeah, and Continuum, that was part of the Maven project.
And on the other side, we also began to get monitoring tools. Before, the way to monitor one application was to look at a screen with a green light if the application was running and a red light if it was stopped. And then you needed to go to see what was the problem. Then we had tools like Nagios, Zabbix, Cacti, and you could begin to get some metrics and to see the state of your application and getting some insights. It changed the way as applications were monitored.
Yeah, so we got a whole bunch of new toolings.
It was wonderful, but it means that developers had to learn to use all that.
All the tools, adding a bunch of complexity layer.
And think about the developer who last year had to learn Ant and Ivy, and this year needed to learn Maven again.
Yeah.
Complexity. And of course,
There was
most
only
of
Bash.
these tools had layers and layers
Exactly.
of Bash.
It was all glued by Bash. And
Let's
it's still
take-
glued by Bash.
Let's go on time. Now we have tooling.
Tooling, now we need methodologies.
Yeah. When you have tooling, you can begin to evolve your methodology. You can leverage on this tooling to change how do you things. And it was, at the beginning, I had a lot of hope. It was in 1999, the Extreme Programming Manifesto, simplicity,
Respect,
communication.
courage, and the name extreme programming. I was feeling like a skater in the programming
It
world.
was
You know?
shooting X's.
Yeah, it was so cool.
So 2000 attitude.
Yeah, listening
was
to
nice.
Blanc.
On paper, it was wonderful. And even better, 2 years after, the Agile Manifesto. Individuals and interactions over process and tools.
Collaboration,
I really believe in that.
flexibility.
It was really a good moment. We were going to breach all those corporate walls, to break down silos, to work together
That
hand
was
on
the
hand.
solution.
It was so hippie.
Yeah, yeah. But.
But
There's always a but, like once upon a time, you know. But one day, the business of agility took over. And I just let you profit from all those nice slides. I'm so proud of them. There came a whole business around all those methodologies around Scrum. I would say.
That was the idea. I remind you, just a second, individuals and interactions over process and tools, and then you have a Scrum. And the daily and all that.
Daily stand-up,
And the sprints.
retros, sprints. Oh my God.
And what about the tooling?
Oh, the tooling. Oh my God, the tooling.
Who here loves Jira? You also love Jira.
We recognize the backlog here. You all have that. I know it. And story points, and it's just tickets. It's just bugs.
Yeah.
I want to code.
I think we got betrayed. We
Yeah.
got a good hope, but in fact, it was back again to the industrial model.
Exactly, because with sprints, they were cutting our job into small pieces of sprints. And basically, we were coming back at the Taylorism, where, yeah, you work as a blue collar on one part of the software. And that's my personal opinion, but I think stuff like Scrum and Safe are bringing us back to the industrial world.
But we have a new hope, as George Lucas said.
Ooh.
DevOps. Yeah, nice. Now we are going to break down the wall between devs and ops and work together hand on hand. It was nice. But, again, companies decided to implement DevOps patterns or more anti-patterns, especially began to get a cheap way to have one person to do 2, 3, 4 jobs. Because, what the fuck? I am in Spain, I can say fuck.
Yeah.
What the fuck is a DevOps engineer? Seriously. Or a DevSecOps. Or a DevML ops. DevDataOps.
Yeah.
DevSecDataOps.
Dev AI or Dev Gen AI data sec ops.
Dev everything ops. It is really nice. You look at LinkedIn and some titles, Dev AI Data Sec Ops. This one is a real one I have seen.
Yeah.
That means that either that person is a superhero and he knows everything about all those domains and he does the work of 5 people, or that companies are making a complicated scam in order to reduce workforce and make everybody to do things they are unable to do.
Yeah, probably.
And of course,
And so we have the cult of agility and DevOps, which added, again, complexity. We are not making the life easier of the developer here. Look at the cat. The cat is a developer, of course, and he's not that happy. But let's add something. And of course, Bash will still be used. But let's add another layer. Ooh, the cloud.
yeah, we are in 2010, 12,
yeah.
and we began to have public cloud. It was wonderful. Your applications were floating in the clouds. In fact, it was all the idea of a retailer company, Amazon, who say, hey, we have a lot of infrastructure that before Black Friday they are fully used, but in the middle of summer at 2 in the morning, they are only used at 20%. We can maybe get the excess capacity and sell it to people for time to use. It was a nice move, but for companies, it was okay, maybe we can have things in a more flexible way. First consequence, we had to learn to automate things. If we want to go from those bare metal servers to getting instances and database on demand, we need automation. But from the developer's point of view, it was wonderful. We changed for a model of purchase order. Hey, I need a new server. Okay, we will ask your manager if he agrees or she agrees. You will have it in 2 weeks to a self-service model. Hey, I need a new instance. Here you have 30 seconds after.
Yeah.
So for developers, on paper it was super nice. You got empowered.
Infrastructure is only one click away.
Yeah, you have a big power.
Yeah,
but
and
with
we will
big
even remove
power,
with big power come big responsibilities, yes.
And everything becomes distributed. Okay, we found a fancy name for distributed.
Distributed computing is, we decided to call that cloud native.
Cloud native. Okay, it means that as developer, you need to think all your application to be able to be deployed in several concurrent instances and all that. Okay? And sysadmin began to code because who was doing all those automation? Not developers usually. Sysadmin who had never done everything besides Bash, and now they were using Python and things like that to do this automation. Monitoring, observability, and new roles.
And again, we are in Spain, so Horacio told me, I can say, what the fuck is a system reliability engineer? Well, I think it's just a fancy name invented by Google to say that system admins can code.
Or maybe developers who administer systems.
Yeah, more or less.
Okay, something like that. In fact, as a developer, now you don't only need to learn some new methodology and some new tools, you need to learn to decrypt the catalog of a cloud provider with 250 products.
Yeah, and once you learn them, your boss went playing golf with the guy from Microsoft, and then you have to
switch provider.
To search
yeah.
another provider.
And of course, if you open the hood, there are lots and lots of bugs behind. But, okay, so now we can automate. We can go further. We can begin to do declarative infrastructure. I mean, do you remember where containers arrive? From developers' point of view, it was nice. Okay, you had to learn containers, but then you will be able to deploy things and use in your computer the same thing that in production.
I'm a developer. I love containers.
Yeah, but even if you are a developer, you can understand that that isn't a production architecture.
Implementation.
Because from the sysadmin point of view, you also need the same thing than before.
Yeah.
But, hey, next trend, microservices.
Oh, yeah.
Before you have one big application, now you have 25 micro applications. It is nice for developers. You only have to worry about your small application. But from the sysadmin point of view, that means that before you deployed only one app, you securized one app. Now you deploy 25.
Yeah. And yeah, but you could just hire an intern for free.
Yeah.
And
In fact, in order to do that, we could have an intern. Hey, guy. Hey, girl. Welcome to the company. You need to deploy this microservice architecture. You are going to have 25 containers. Here you have the computers, deploy it wherever you want, and you do some monitoring. If one container goes down, you put it up, and you do some metrics. Yeah, you are an intern, you can do that.
Yeah.
I will be at the coffee room.
Yeah, and don't forget my coffee.
Yeah. If you have understand this metaphor, you have understand the next trend, Kubernetes. Because Kubernetes is only the electronic version of your intern. You are going to tell Kubernetes what you want to deploy. It is going to do it as well as an intern. It means it is going to take some decisions, not always the good ones, but most of the times it is going to work. Nice. But now you have Kubernetes, and you need to deploy Kubernetes in many clusters in several environments.
Yeah, but we have...
and you need to deploy, and then you need to put all your YAML files.
Yeah,
How do you deploy that?
Yeah, so you have a few options for that again.
Oh, yeah.
You can learn
Puppet.
Chef or Puppet. Good luck.
You can use Ansible.
Or Terraform.
But now,
Oh, no, but IBM, though, you can use Terrible.
yeah,
Yeah.
nice.
But again, we are adding complexity.
Containers, pods, services, Kubernetes, Ansible, Terraform, Terrible. Our cat is even sadder.
It's really...
And if you open, you still have the same crazy bash script under that, but that's another problem.
That's another.
So let me resume things. We are in 2024. I am a junior developer. I can dream I am a junior developer. So I want to deploy a Java application. I need to know all that.
Yes. So start learning now.
Too many concurrent options. That's the first problem. And, okay, what are you going to use to do infrastructure as code? Puppet, Safe, Ansible, Terraform, OpenTofu, whatever. For every problem, you have tens of concurrent solutions. And you have the responsibility.
Yeah, because what we try to manage is to offer self-service to the developer, and the developer is really excited because he can pick whatever he wants. It's like going in a supermarket, and everything is free. And so we get really excited about that. But then, like, you have the Jenkins stuff, and you have 5 different ways of deploying Jenkins, and that will add a lot of cognitive load to the developer. Which way, and we got this feedback last week when we did that talk. Someone saying, yeah, in my company, there are 5 different ways of deploying a new Jenkins.
Only inside the company, they have 5 concurrent workflows.
And each team is fighting
deploy.
for their solution.
Yeah.
No.
So you have a lot of products. You have a cognitive load problem. And we are here to talk about one possible solution. Yeah, one possible solution today. Maybe in 10 years, we will look back and did, hey, yes, another layer of complexity.
Maybe next year.
But for the moment, it seems it could be a way. Yes. Let's talk about it. Yeah. Platform engineering. What is it, Sebi?
Yeah. Basically, it's providing a platform, as the name suggests, where the developer can go, and when he starts a new project, you just have to click or git push, we will see that, for a streamlined offering of self-service. And we move all the cognitive load that he has. The developer, what he wants to do, or she wants to focus on building features and nothing else.
So, in one hand, the developers aren't going to become experts of all the technologies, and on the other, when they have a need, they are going to get an off-the-shelf solution for that need. That's the idea of the platform.
Exactly.
But I have already used that in almost all the companies I had, no?
In fact, for 10 years now, for all the big accounts that I worked for, they all had a platform already. They just didn't know it was called a platform. But the bigger issue is, most of the time, it was the really smart developer that developed that with a homemade solution, and now he's not working anymore in this company. And their platform is not really in good shape. So we should build your platform on solid basis, and let's see how we can do that.
That's the difference. Now we begin to have platforms using open technologies are created specifically to make developers' life easier.
Yeah.
The idea is that when you create a platform for your developers, so when you use a platform for your developers, you are going to empower your developers to reduce the entry barrier and reduce the complexity, making your developers more productive, but at the same time, making them happier. That's why we as developer relations people love this kind of solution.
Empowering them. Ooh. So what can we do? What are the 3 big pillars of platform engineering to deploy platform engineering into your company? First, you have to find a way how you can offer this off-the-shelf services, how you can provisioning them. We will cover that with the GitHub approach really quickly. Then it's not only about technological choices, it's also about organization choices.
Yeah.
And we will cover that in a few slides about how you can shape your teams so it will work efficiently. And of course, then you need to build your platform itself, and we will quickly see some basic building blocks on how you can
achieve that. Will end with some concrete examples using Kubernetes or without using Kubernetes. Let's go.
Okay.
GitOps.
GitOps.
What is this fancy thing? Git, I understand. Ops, I think I understand. What do you mean by GitOps?
GitOps is really, really easy. Since we saw that we can have infrastructure as code, we can have everything as code. And code, well, you can put that in Git. Okay? And everyone knows how to use Git, even the sysadmins or the SREs.
Oh, okay.
Okay? And all the power of Git, doing pull requests, reverting commits, that is something really powerful. So the idea is, everything that you declare, a new Kubernetes cluster in Terraform, for instance, I don't know, a deployment with a service, with an ingress for Kubernetes, these are YAML files. Ooh, YAML. And the only thing you do is committing that to a repo. Git is the single truth source of truth.
And then your platform automates the getting from the GitOps to the Terraform deployment, the Kubernetes cluster creation, the deployment of things on your cluster, and whatever.
And there's just one flow.
Okay.
Just creating your YAML file or whatever file, and push it into a specific repo.
If you are able to do that, you can enhance collaboration between developers and ops without having to try to do some more complicated DevOps workflow. You can get better visibility and auditability because all the operations are in Git. There is no sysadmin who is going to connect to a production server to do a hotfix and forget to document that.
Oh, and even if you do that, a good GitOps approach will revert that because the source of truth is in Git. And a good GitOps tool will detect any change
so
in the...
you have enhanced security reliability, and of course, you can simplify all the provision and part of the problem.
Yeah.
Nice.
Okay.
So we have GitOps.
So that's it. Now we know how the developers can use this self-service.
GitOps is a technical thing. It is easy. One of the most difficult part is the organizational part. Who here was at the keynote this morning? Do you remember Manuel Pais talking about team topologies? He is one of our heroes. If you are here in the room, thank you. The idea is you cannot have this kind of platform engineering if you don't modify the organization. The organization must be ready to create, maintain, and use this platform. Yeah. What does it mean concretely?
Concretely, and just to specify that is the ideal situation. Of course, we understand that your current topology can be pretty complex, but this is where you should tend to go, okay? So you have the platform team will build the platform, okay? And we will see in a few seconds how to build that. They provide the platform. Then you have at the top there, the stream align team. These are the consumer of the platform. Consumer means that you have to treat your platform like a product. And they only do consuming your platform to build features for your company. Then, of course, you have some teams that work on more complicated stuff.
Complicated subsystems.
Like security. And then you have a team that is here to facilitate, to help, to do internal advocacy. They don't deliver anything, they facilitate. This is what you should try to go to. And then you have different types of
interaction, because those teams need to collaborate together. The platform team must create the platform, but a platform is never done. It has to be enhanced to take account of new needs from developers, to modify the product they propose according to the new product that appear or the new needs of the company, and need also to collaborate directly with a new product, have a new need that the current platform cannot help. The complicated subsystem also need to collaborate with others, but most in a as-a-service way. They create a security as a service, identity as a service, whatever, and put that as a black box for the other teams to use. And then the facilitating of the enabled team means that they work with others to be sure that the different teams can enjoy of the shared experience of all the others, and we can go on.
Yeah, exactly. And I suggest you to go to,
We can talk now about the platform engineering itself.
Yes, and let's see what is exactly, so it's all about the idea, and you probably have heard that before, paving golden path, making sure that you make the life of the developer easier, but also making sure that the developer don't make stupid choices, for instance. If you provide some way of him so he can spin up a Postgres, you want to make sure that he doesn't deploy that on any random cloud provider, that he use some schema, specific schemas, that he introduce some airbag. And that is stuff that you can abstract him away from him and put that in your platform.
But you always have to keep in head that you are empowering developers. If your platform doesn't give enough choices for the developer to do their work, they are going to do some shadow IT and do it outside. So your goal is to give the good solutions to your developers.
Yeah. And of course, you won't be able to solve everything, but before that, again, what should the platform team focus on?
This platform team need to have a clear mission, and that's very important because they are there to build the platform, not to do all the random tasks that other teams don't want to do. They are the builders and the maintainers of the platform for all the others, and this platform should be a product.
Exactly, but not like building a bridge, because
No, like a software product.
a software iteration and really treat the platform as a product, because remember, the stream-aligned team will be consuming this.
You have your internal customers, you get their feedback, you get their needs, and you iterate on your product in order to be sure it do it.
Yeah, but of course you cannot solve everything. So it's really important that you focus on the current problems that are common to all the teams.
Because your platform team is never going to have enough time and resources to deal with everything. Focus in the most important problems, the problems that are common, and don't forget in the company culture to include the idea of what the platform team is doing is valuable. What I mean, they are doing basically a kind of glue. They are putting tools together in order to do developers' life easier. From a traditional company point of view, it is worthless. They aren't adding to the product directly, but glue is very important. I really like a lot this pic from the Superman film. Basically, the rail is broken, the train is arriving, and it is doing only that, the glue. It is keeping everything together in order to make the train go on. And that's the role of a platform team. And this kind of glue, it is very worthy. So that need to be understood by the company, and you need to have a budget and to have a value in that.
And don't try to reinvent the wheel. That's a classic one. And don't use technology for the sake of technology. You always have people in your company that want to put in place really nice stuff, but for no valid reason. So it's important to keep that in mind. We always see that, don't reinvent the wheel, but when you're creating your platform, really keep that in mind again.
So we have 7 minutes, not so bad.
I'm not sure how we are. But
we are going to try to do some concrete things about how can you do it in Kubernetes. So let's go.
So you're on Kubernetes and you want to build your internal developer platform.
Yeah.
Right? First thing, don't put everything in Kubernetes.
That's an important one.
Yeah.
You don't need to put your database or your legacy application and your external data source, everything in Kubernetes.
If you need a Kafka, go to Ivan. If you need a Postgres, you can go to Ivan as well, or to Clever Cloud.
If you have your legacy API, don't try to shoehorn it into Kubernetes.
Yeah. But Kubernetes can help you operate all of those stuff.
How?
With the operator pattern. And for me, we always say Kubernetes is a container orchestrator. That's true, but it's way more than that. For me, the most powerful feature of Kubernetes are the operators, and specifically the CRD plus the controller couple. So basically, what can you do with operators? You can extend the API of your cluster. You can define that in a CRD, which is just like a Java class definition.
That means that I can explain to my Kubernetes how to deal with the external Kafka enable and the external PostgreSQL in Clever and the old legacy API?
Exactly. As long as you provide a CRD and a controller, which is the pod, the logic, okay, that will operate that, you can do whatever you want in Kubernetes, and you will benefit from the whole power of Kubernetes. And the scaling, the scheduling, the reconciliation loop. Honestly, Kubernetes is super useful, super powerful.
And if I don't even need to code those operators. There are lots and lots of them.
There are a lot of operators, yeah. You can use existing operators, or you can build your own operator. And since Codemotion has a historical Java background, you should try out the Java operator SDK. I swear it's pure gold, and you should use the Quarkus extension for it.
So, okay, let me understand. We have now in our cluster 100 operators, and our cat is sad.
Yeah,
again.
because we have so many operators. So what we could do is create an operator to manage the operators.
Yeah, so yet another complexity
Yeah,
layer.
why not?
No,
No,
you do
that-
have a better
okay,
option,
okay.
please.
Yeah, there are some other options. One that I would like to highlight here is called Cratix. So you go to cratix.io. It's an open source solution. And basically, you define one CR, one promises, where you simplify your custom resource. And then you can have a lot of different operators as dependencies. And then there's a system of pipelines and workflows. It's pretty simple, but as input, so the developer, he just has to submit a really simple YAML, and on the back end, under the hood, Cratix will generate all the different custom resources for each of the operators. You, in the Streamline team, you won't even notice that your small YAML spits out 10 different YAMLs for 10 different operators. Really try it out. It's pure magic and pure gold.
Need to learn about Cratix or not?
No, they just need to learn how to do a git commit and a git push.
So we are using your GitOps things.
Yeah, exactly. Then you come back to the GitOps thing. And you might think, which GitOps solution should I try? So here, we just pick one because it's our preferred one. I suggest you should go for Argo CD.
Yeah.
Of course, it's a CNCF project. It's more or less, I don't like to say the word winner, but it's more or less, yeah, it's becoming the winner.
It's easier to use and most powerful. So
Oh, and the UI is so nice when the things turn green. I love things turning
and the
green.
logo is cute.
And
That's
the logo is
another
cute.
thing.
The logo
Yeah.
is really cute. That is a valid reason to choose Argo.
So we have Kubernetes with operators. Either we get them from the internet or we code ourselves, and we manage them with Cratix, and we use Argo CD, and we have a small and quick internal developer platform for Kubernetes.
Exactly, yeah.
Nice. But everybody don't love Kubernetes, if you can't understand that. Because I really miss this kind of simple workflow. What will be the current version of this workflow? Well, for me, it will be I write my Java code in a modern editor. I put everything into Git and use GitOps, and my application is deployed. I don't want to know about your operators and all that. We can do an internal data platform without Kubernetes. Yes, we can. We can by using products. It's an example. It's the company I work for, but there are others. Products that do Git to prod. In fact, you put your code, your Java application, your Python, Node, whatever, in a Git repository, and with a PaaS, Platform as a Service solution, you go Git to prod, deploying in one or several instances with the rules you want, with the database you want. As you as developer, you only need to learn to develop your Java, Python, or whatever code.
Yes.
So what is the right platform? It depends on your company. If you already have a Kubernetes culture or not, if you have a big team or not, there is always a solution. Try to find the right one. And in order to end, let's look at some links. You have links to everything we have talked about. The presentation will be on Twitter just after the talk. And basically, I especially suggest you to go to the Platform Engineering and Team Topology site. And again, Manuel Pais, if you are here, thank you for the Team Topologies book. It's one of my favorite books these last years. And thank you very, very much. And we have even 1 minute for questions.
1 minute plus the 4 minutes for the question answer.
Yeah, we did it.
Thank you.
Thank you.
And